नमस्कार मित्रांनो. In topic number 13, carbon an important element. In earlier video we studied the properties of carbon and the first crystalline form, that is diamond. Now in this video we are going to study the second crystalline form of carbon, that is graphite, then Fullerene, and then non-crystalline amorphous forms. Okay, let's see the graphite, where it is found in Russia, New Zealand, America, and in India. Graphite is found. Okay, we all know about the graphite, or we use it graphite where we use the pencil. See, pencil, inside the pencil, the black color little pen, that is nothing but it is a graphite. Okay, this process means the use of graphite was discovered in 1795. In 1795, from that time the graphite is used in a pencil. Okay, see the structure of graphite. In a structure, one carbon atom is bonded with three carbon atoms. One carbon atom is bonded with three carbon atom. Okay, so this one also bonded with a three carbon atom, this also bonded with three carbon atom, then this carbon also bonded with a three carbon atom, this one also bonded with three carbon atoms, this also bonded with three carbon atom. Okay, so each carbon atom is bonded with a three, and that's why it got a, see, hexagonal molecule of graphite got a hexagonal layer of graphite. That's why the graphite made up of the sheets of layers, or sheets or layers of a carbon. In graphite, sheets or layer of a graphite is formed, and that's this layer easily slip while we are writing. It form a layer, so these layers slip out if we apply the pressure. So in pencil, when we use graphite, because of this structure, the graphite can be slip on paper. Okay, this one layer of graphite, it is called as a graphene. Each layer of graphite called as a graphene. Okay, graphite's properties are, see, it is black color. In nature it found it is black color, soft, brittle, and slippery. Why it is slippery? Because it has molecules have layers. Then inside the graphite there is a layer of graphites are forms. So there are free electron moves continuously within entire layer. Okay, and because of that reason, because the free electrons are moves entire, and that is why it is a good conductor of electricity, because it has a free electron. That's why it become good conductor of electricity. Then due to this layer, graphite can be used uh, layer, it has a slippery layer, it has a slippery layers, and that's why it is used in to writing on paper. Okay, then its a density is also high, and it is 1.9 to 2.3 gram per centimeter cube. It is also high. Okay, and it also does not dissolve in most of the solvent. Diamond do not dissolve in any solvent, and graphite does not dissolve in most of the solvent. And because of that property, it is used. Where it is used? It used to make lubricants. Lubricant, because it made of the layer, so the layers can be get slip, and that's why it act like a lubricant. Then second use is used to make carbon electrode. Carbon electrode in a battery cell, in a dry cell, the electrode is used, because this graphite is a good control of electricity, and that is why it is used in making the electrodes. Then third use is it is used in a pencil for writing. Fourth use is that it is also used in a paints and polish. Okay, and graphite is used it is also used in a arc lamp. That arc lamp will give the bright light because of this graphite. So that is uses. Graphite is also very important. Then third element is allotrop, is a Fullerene. Okay, it rarely means graphite and diamond found mostly in a nature, but Fullerene found rarely. It is found in a soot and in a interstellar and in a interstellar space, in a soot particles and in a interstellar space. Okay, it was first the first example of the Fullerene is example is a Buckminster Fullerene. The name of Fullerene is, that is a Buckminster Fullerene, is given on the name of architectures, that is the Richard Buckminster. हा एक आर्किटेक्ट आहे. या आर्किटेक्टच्या नावावरून या फुलेरीनच्या लढवला नाव दिलं आहे बकमिन्स्टर फुलेरीन. का? तर द स्ट्रक्चर ऑफ Fullerene. In a Fullerene, it contains C60, means 60 carbon atoms. How much? 60 carbon atoms are resembles the structures of the geodesic dome. The Buckminster structure is look like a Richard Buckminster. He architect this structure that is called a dome design, geodesic dome. And the Fullerene, which contains the C60 molecule C60, that carbon structure is also look like a geodesic dome. जे रिचर्ड बकमिन्स्टरने एक रचना केली होती, स्ट्रक्चर केलं होतं, त्यात तो जिओडेसिक डोम त्याला म्हणतात. आणि ह्या फुलेरीनची रचना आहे त्यामध्ये C60 म्हणजे 60 कार्बन, त्याचं स्ट्रक्चर होतं. दॅट स्ट्रक्चर ऑफ दॅट कार्बन कंपाऊंड इज ऑल्सो लुक लाईक अ जिओडेसिक डोम. म्हणजे रिचर्ड बकमिन्स्टरने जे डोम तयार केलं त्याच्यासारखं दिसतो. अँड दॅट इज वाय ऑन हिज नेम दॅट Fullerene गिवन नेम ॲज अ Buckminster Fullerene. Okay. On the research of Harold Crota, Robert Curl, and Richard Smalley, these three scientists got a Nobel Prize on this discovery of this fullerene. Under this fullerene, they got a. In fullerene, there different type of fullerene: C60, C70, C76, C82, C86 type of the different type of the fullerenes are available, are found in the nature. Fullerenes, see the property of fullerene. It found in the form of buckyballs and buckytubes. Molecules of fullerene found in the buckyballs and buckytubes in the form of, okay, या फॉर्म मध्ये सापडतो. Then there are 30 to 900 grams. In fullerene there are 30 to 900 carbon atoms are present in the one molecule of fullerene. फुलेरीनच्या एका मॉलिक्यूलमध्ये how many 300 to 900 30 to 900 carbon atoms are found, and it is soluble in a organic solvent. This compound is soluble in organic solvent, means like alcohol, etc. Such as carbon disulfide, chlorobenzenes. In this organic solvent, it is soluble. Because of its property, it is used. It is used as an insulator. It is a bad conductor. That's why it is used as an insulator. It is used as a catalyst in water purification. It is used as a catalyst. And fullerene also, in a specific temperature, in a certain temperature, it acts like a superconductivity. That means it is a insulator, it is a bad conductor, but at a certain temperature, this fullerene become a good conductors, and that is why it is called as a superconductivity. Okay, these are the three forms of carbon crystalline. Then see the non-crystalline carbon. This non-crystalline carbon also called as amorphous forms. Amorphous means they are powder like, means their molecules have no sharp edges. In this, aluminum carbon atoms is not regular, as well as the atoms have no sharp edges. Coal, charcoal, and the coke are the example of non-crystalline carbon. Okay, first see the coal. It is fossil fuel. Fossil fuel means it found in a earth crust. It contain what it contain? It contains carbon, hydrogen, and oxygen. This coal contains these three components. Okay, three substances. As well as it also contains nitrogen, phosphorus, and sulfur. Okay, means in a coal that elements are also present. Okay, according to the presence of carbon, how much carbon atom presence? There are four types of the coal is there. First one is called the peat. In this peat, it is the first step of formation of a coal. It contains high proportion of water and less than 60% of. It contains high proportion of water and less than 60% of carbon in the coal. It is the earlier stage in the formation of a coal. Okay, in which water is more and the carbon is less than 60%. Okay, therefore it do not give a heat. It do not give a lot of heat or more heat. That's why it, okay, because less percentage of carbon. Then second one is lignite. Lignite the peat is transferred into the lignite. Okay, because as the pressure increases and the temperature increases inside the earth, from the peat water is evaporated. As a result, the carbon content will be increased 60 to 70 percentage in the lignite. The carbon present 60 to 70% carbon. It is the second step of formation of coal. Okay, then this lignite is then converted into third type, that is called the bituminous coal. In this bituminous coal, the carbon percentage is increases from 70 to 90 percentage. Okay, carbon is, and this is called the third stage of formation of a coal. Then, because of the pressure, the bituminous coal is then converted into anthracite, in which the carbon percentage increases up to 95 percentage. This coal is hard. And contains 95% carbon. Okay. Then this anthracite then completely converted into coal. It is the fourth stage in the formation of a coal. Okay. Then the second example is charcoal. This is also called the non-crystalline form of a carbon. Okay, charcoal is made from animals. It made from bones, and horns, as well as from it also made from the plant by combustions of wood in insufficient air, means in absence of oxygen. Then this wood convert into the charcoal. Okay, this charcoal and coal both are uses. Okay, the coal is used in factories and companies and homes also as a fuel. Okay, they are also used in obtain coke, coal gas, and the coal tar. To get coal gas and coal tar, the coal is used, and it is also used in a thermal power plant to produce the electricity. Okay, then third allotrops, non-crystalline allotrop, is a coke. Coke is produced from the coal, pure coal. From them, the coal gas is produced, and then whatever remaining, that remaining coal gas is taken, and whatever remaining, that is called as a coke. Okay, means coke is formed from the pure coal. Where it is used? It is used as a domestic fuel, as well as it is also used as a reducing agent, and it also used in the production of water gas, that is a CO plus H2, and also used in the production of a producer gas. The producer gas means CO plus H2 plus CO2 plus N2. This is known as a produced gas and this is known as a water gas. Okay, in this way there are the different forms of carbon compounds are present in nature. Okay, in the next video we will see hydrocarbons, that is basic organic compounds. Thank you.